This
And
conference will now be recorded.
so Yogesh is here, but we'll have to leave early, I believe.
Yeah, Drew, I have something that's about to happen, but I'm not sure how long I'll stay. I'll probably stay for the first half.
Okay.
So yeah, let's try to get through this part that we had.
Yeah.
The table that Mark is here, and I think Vilas sent a message that he made some changes there. So let's take a look there.
He did. What I'd like to do really quick, I think that uh, Vilas made a couple of minor changes. Like he said, when an interrupt is sent to interpost firmware such as x86 system management mode or ARM ZL3 firmware, and then as a result, firmware. I guess I don't like that comment, but I'm gonna well, it's not preferred is understated, so I'll deal with that with him. But if it's okay with you, I'll just accept the x86 or ARM ZL3. Is that controversial?
So let's see. The context he's setting is because of some security problems inherent in x86 EL3 firmware or avoid some of the security problems inherent in some device, but it is still undesirable. So, okay, this is some information, and this is setting what? I mean, this is in the section on creation of component error
Oh,
log. So how does this help in this
this is-
context, actually?
I think this is part of the problem context. So we
Yeah,
had just, we had said,
but
hey, firmware
hmm.
first solve the problem, but wait, it doesn't.
So creation of component error logs is what I'm looking at to address this issue of gathering logs created. Um, so the last line in PFA paragraph reads, it is often important to correlate error logs gathered by software such as machine check banks with hardware logs to address the issue. Firmware first approach is there, but
It has
I mean,
problems.
yeah, I think I think it's okay, but I don't know if we really need to compare and contrast ARM and x86 at this point. If our general point is that, hey, you know, these methods have security concerns, and I think the third from the second sentence from the last, and firmware first error logging can cause problems due to both performance and security impact vulnerability. As a result, it is not preferred by most CSPs. I don't think we need to delve into details and comparing to proprietary solutions, right? That's my view.
Okay. What do anyone object to me? Just, I guess I can take this out. Oh, to perform error logging, take that out, and then get rid of the sentence below. Is that okay? Here, in fact, I'll just do it with suggestion turned on. So those will be the changes.
Yeah, I think it gets the message across, right? Do you agree?
Any objection? Okay, I'm going to do that. Okay, and then I need to debate this I want to make this worded more strongly. It's not just not preferred. It's, we are actively trying to move away from it. So let's go down to the table then. So, so it looks like I'm just going to scroll through. It looks like he deleted almost all the text in the bullets because it's almost always the same. And so what he did is he put a summary at the beginning. BMC first error logging is the only error handling scheme which is feasible in all scenarios. And firmware first is feasible in many scenarios. It's not recommended by CSPs due to security and performance concerns described earlier. So I'm fine with what he said here. And then we can take all this out and we can get rid of the color coding. So, Mark, this is like between you and me. We were arguing last time. Are you okay here?
I don't see anything that burns me right now. So the idea is, I think that's all true, uh, and I don't at this point I don't object.
Okay. Well, we're going to submit this. So if you object now, because we're running out of runway.
I
Uh,
Yeah, I don't want to quibble. I mean, right? I can't argue the point, right? It's feasible, and ultimately, what CSPs prefer is one thing or another. I mean, I, the idea is I don't think there's any argument there.
okay. So I'm just accepting all these changes. Let's see. I'm accepting the obvious changes so that we can focus on uh, the ones where we need to debate. Okay. Oops, I think I did one too many. Okay. Oh, I don't know why it did that. I guess there are two comments. I accepted Villas's comment and it blew yours away. I'll skip that one. We'll come back to it. I mean, this is cleaner, and I need to go back and get rid of the colors. I'm fine with that. Uh, I don't know what's going on here. Um,
I don't
my
know that the
opinion,
color matters much, right? I just, if you're going to use the color, right, put it, make everything the same, or not use color, and they'll all be white.
yeah.
So,
I mean, I thought that's what we agreed to last time, so I'm fine
yeah,
with just making it white.
that's fine. I mean, my only thing is I didn't want to see a feasible box made red, right?
Sure. Yeah, that makes sense.
And but I will say, where you have the red, you have the description as to why it's not feasible. So I mean, my thing is that's all I really want is anywhere where there's something that's not feasible, describe why. That's
Yeah.
all.
So, okay, I agree. I agree. Okay. Uh, I'm gonna just let's see. I'm just trying to clean up the obvious ones. Okay. I tell you what, we're at a point where we can now discuss things. So, okay, he looked at this and said, doesn't this mean, I'm just deleting a period here. Doesn't this mean it's kind of not feasible? And corrected error. So I think infrastructure, I think it may not, I think what I would say is may not be feasible for OS first with infrastructure. Uh, but I think it is generally feasible. So I don't know. I'm okay with it the way it is. What do you think, Mark?
I again, I think I agree with what's stated there.
Oh,
And
just as a,
well, I mean, here's the problem, right? Is there a requirement in OS first mode with the infrastructure row that the OS has the ability to manage corrected errors?
I think if we say it's feasible, like if we say that we're doing OS first, for it to be feasible, the OS has to be able to do that. Yeah.
Right, but there's no requirement. That's the
Well, there's
problem.
no,
There's no requirement. The idea is, you know, if you're a provider and you're running an OS and the OS doesn't manage errors, how are you to know? I mean, the idea is that, I would say most OSs would, but if you're in a virtualized environment, I mean, I don't know. Are you going to manage errors within each virtual machine?
Oh, well, yeah, no. But I think this is more saying that, like, you might use a hypervisor that doesn't have a plugin for your machine. That's more likely.
Yeah,
Uh,
and the idea is there's no way for the platform to know that, right?
that's right. That is
And
absolutely right.
yeah, and so the idea is that that's why it becomes, I think, a caution, because there may not be ability in the OS to manage.
Okay, but there are feasible, but there are limitations.
Now,
Is
again, I would not be vague. If you're going to call it, describe it in detail, right? The idea is, limitations is too general. If you're going to, whatever we call out here, it should be detailed enough that people understand exactly what we're describing.
how
So,
about this? I'll just say
I think
potential.
I think I think we should take a view that it is feasible, means feasible unconditionally. No matter what is thrown at it, it's feasible, and by that criteria, this should be not feasible.
or may not be feasible. Again, it could
Yeah, I mean,
work.
of course, sometimes feasible, sometimes not feasible, right? Kind of thing. So, if you throw something, some restricted, limited OS agent which does not do what we ask it to do because it's out of your control, or then you have a not feasible case, right? But if you do the opposite of that, then you have feasible case, right? So it's kind of in
Okay,
the gray area.
so that's why I said may not be feasible. I just put a concern. I just said concern, and the concern explains why.
Yeah, that's detailed enough for me. I think that's provides enough information for a user, a reader, to understand what we're conveying.
Okay, so sounds good. So then I'll move on to this one. So so it says BMC will have limitations for timely response. Uh, that it just depends on the implementation, Mark. So I'm inclined to just
No,
leave
no, no. I think that's the so this is the problem, right? That the BMC RAS function, it's by requirement limited to 1% of the BMC. And that's so it doesn't conflict with all the other tasks the BMC is doing. And
we don't
that
we
in
don't
and of itself creates a problem where it's you're trading one set of problems for another. The
I think that
BMC the
yeah,
BMC will always be limited.
that's a HP limitation, by the way.
No, it's
It's
not. It's
it,
that's an industry limitation. It's not
no,
HP at all.
well, it's not universally held. Let's just say,
Well,
but
but Drew, if you're going to do RAS offload to the BMC, how much bandwidth can you consume? And
so
and right, because I mean, I'll just say this. I think I could have a dedicated processor to doing RAS offload, and I could fully consume it. But that's
so
not the architecture that we're working under. The
right,
architecture that we're working under says I've got 100 threads running on the BMC, and they all do important functions.
well,
And I can't interrupt. I really can't interrupt any of them. And so
let's just
the way that's managed is by simply saying nobody gets to consume more than 1%.
so we don't follow that limit, but that's fine. You have that limit. Somebody has that limit, because I'm sure that didn't come from just out of thin air. So I believe you, Mark. We don't follow that limit, just so you know. But also, uh, like on a HP Superdome, they've historically used microcontrollers for logging things that were far more limited than the BMC. And if you look at what we're proposing here, um, we have these out-of-band hardware assists. So I think that what you're talking about is a limitation that exists with current systems today. What we're talking about is requirements for a future infrastructure. And if you look at like what Antonio has proposed with the RAS API, this vendor code becomes a pretty thin shim where the out-of-band hardware does a lot of the heavy lifting. So, I'm just not, I think we don't need to include that limitation here. I think that's a limitation of current implementations.
Well, I would just
So
argue it's going to
can we go back
depend
to the
entirely on
table?
what else your BMC is doing. For example, is your BMC doing thermals? If you're doing thermals, then you can't really interrupt that flow because that's a real-time process, and you don't want any thermal excursions. So whatever you put on this RAS function really can't interfere with the critical operations that the BMC is doing. So I simply ask the question, what else is your BMC doing, right? I think I could easily consume 100% of the BMC if I was allowed to.
If you design it poorly, absolutely.
Yeah,
What were you going to say,
So
Antonio?
through this kind of error, can we have an example of this kind of error? Just to try to ground this more on specifically this cell.
Yeah, how about a really common one, a corrected memory error?
But a corrected memory error is not a recoverable. That's a corrected error. That's the previous table.
that would
Oh,
fall
yeah,
first.
yeah. Okay, poison consumption, an uncorrected memory
Poison
error.
consumption would be a perfect one.
Yeah, yeah. I think poison consumption is synchronous. I don't think we can do BMC first in that one.
Well, what you would do, Antonio, is the OS has to see it. So that's absolutely right. The OS would get a machine check. That's unavoidable. Uh, but what would also happen is that we would be able to get something from the core that the BMC could see that just said, hey, we had a machine check. Here's what we got. And overwrite rules apply. So if we don't log it and clear it fast enough, the overflow bit may be set. We may miss a log. Oh well.
I agree that we should log it and help us with our data center error database or tracking of errors. But I think this table means it's talking about the management of the error, right? And the management cannot be done in the
Well,
BMC.
it's actually talking about. It's really focused on logging. Um, and and Antonio, I guess when we say management, what we're really saying is how do we manage the hardware? So, like for instance, uh, if you had a corrected memory error, that might be invisible to the OS. We might have cloaked it. Or let's say I have a bare metal machine. When I've got a failing DIMM, I need to know enough to replace the part that is potentially going to cause a problem. And and so that's really what this is about. Of course, the OS has to be involved, and that's actually described in great detail in the section where we give an example of poison recovery down here below.
Okay.
So all
Okay.
of that
So this is more about logging and long-term actions.
maintenance, yeah. How do you log it and how do you maintain the system? And so that's why I'm saying, there's no reason out-of-band hardware couldn't tell me that we did a recovery. I don't. In fact, as a CSP, um, the details of the recovery aren't terribly relevant to me if it's a bare metal system because I don't know anything about the workload. I have no control over it. But if I have a customer who is getting a lot of recoveries, then they're going to be dissatisfied with all the tasks that are dying and the performance impact and maybe some bad behavior from things from processes getting shot. So I need to know so that I can say, oh, hey, customer, we're really sorry. Your system looks sick. We need to move you to a healthy machine.
Okay,
Right,
from
but
that perspective, Drew, I think that the amount of data of a poison consumption is way less than that of correctable errors. So if BMC first can manage correctable errors, it can definitely log recoverable errors. My question was more of, we cannot take the action required of poison consumption. That has to be the OS.
It
And
has
if
to be, yeah,
there is no workaround that. It's like the only way is OS because it's the owner of the task and can kill
exactly.
the
And that's all
process.
right below.
right,
We all agree.
but Drew, I think
Mark's concern was latency, though, right? So I think as long as we address the latency concern.
well, right, but I mean, this is where I kind of come in. It says BMC first, and will BMC first be able to log a poison consumption? Well, the
Yeah.
answer is you don't know. Right?
Okay,
And
it's a BMC in parallel, not a
anything was going
BMC
to be
first.
not feasible, it would be that box that says in these real-time events that happen, there's no guarantee that the BMC will be able to see them.
Okay, now I understand, Mark. So I don't think that's BMC first, Drew, because we're doing a parallel approach. I've
Well,
heard this comment from another customer before, that what we're enabling is in this offloading is parallel, right? The machine check, we don't. It's not like firmware first, where you deal with the error first and then pass it to the OS. Here, the OS gets it directly and the BMC gets it directly, right? Or
yeah.
at least
Well,
that's the
maybe,
flow. So it's
right?
not exactly first. I mean, it's not sequential. They could happen. They're signaled independently. Let's call it like that. And yeah, most probably BMC is not going to be first, right? It's
Right.
unknown who goes first, with most likely
Well,
OS first.
Well, but
OS,
no, but let's drill down on that, because what's going to happen is the OS will be signaled and then it'll clear it.
Oh no, but we're assuming that you can do it in the architecture that's being proposed in this paper. No, they're not competing paths. They're
we're
independent.
Well,
solving the race condition, Mark. I agree there's a race condition today. But what we're
well, no,
saying in
no.
this race,
I mean, there's a shadow, so I mean, you could potentially use shadow, but the idea is even the shadow could get overwritten, right?
That
Unless you're going to run first error, uh, you know, that would stick, but then you might miss later events. But I mean, bottom line
well,
is
there,
you
so
can't
Mark,
guarantee.
actually, Mark, that's an implementation decision. It could be that there's a queue of error logs rather than just one set of machine check banks. You just have a queue of whatever you've logged. It could be that you just have one and you have overwrite rules for it. But we're not specifying the details there. So that's where I don't want to dig too deep on this. I think we're kind of getting stuck and we got stuff to get to.
Actually, I kind of started thinking about this nomenclature of first. This is really based error logging, right? Isn't it?
Yeah,
It's,
it is. It is.
Oh yeah, if
Yeah.
you put base, then I think there's no discussion. It is feasible. It's just a different architecture than what we have today, Mark. I agree, but we do have solutions in the future, right? So
Okay, I will take an action item to go through this entire document and make it BMC based.
okay,
Does that
and
solve the concern?
I just think just the table is enough. But yeah, I think this is
Well, we want to be consistent. Uh,
okay.
so we're always consistent. Um,
Right, but even the BMC based implementation may negotiate with the platform to determine who's going to handle correcteds and who's going to handle uncorrecteds. And
mhm.
in this case,
so,
right,
so implementation variations will be there, right? I mean, no matter what you design, your architecture is, implementation variations are always possible, right? And
I
configuration
agree, Mark,
variations.
and I agree with everything you just said. Yes.
but that's not being described here, right? I guess I would just point out that if you want to call it feasible, I won't quibble. But then what I would put in there is the description, right? Say, the BMC will have to be able to get this, by some means that won't be overwritten by the OS or cleared by the OS, right?
I'll just say a race-free way to get the error logs without interference with the OS. How about that?
or the platform.
Yeah, no, that's fair. Okay.
Okay, that's good.
Okay, good. I think that this is painful, but thanks, Mark, because I think what we're doing is we're making the document clearer. So this is good. Okay, so then let's see. Doesn't this mean it's not feasible? But I think it is not feasible. Okay. Oh, I changed this, Mark, to feasible from not feasible because you said something about warm resets, and you're absolutely right. That was wrong. I agree with you. Um, and I think that that's the case for when it comes to firmware first for all of these. And what I did is I tried to put a note clarifying it. And like I ignored the color coding because I thought that was going away. So, but I think it's feasible if you're able to reset and run code and if you got everything that you needed in the sticky registers.
Right. So I think ultimately we need to distinguish because don't you have two fatals? Yeah, fatal power loss is your next one, right? So
Quite different. Yeah, no power. The
yeah,
OS isn't running. Firmware
so
first doesn't work there.
right, and potentially neither does BMC first, right? But
Well,
the idea is
actually, we defined that as housekeeping power was available. That's what this footnote was.
right.
Uh,
Well, then you have to define what power loss means, right? Um,
we did. I mean, list table assumes that power is available to BMC.
then I would say you then define power loss as not aux, right? The idea is I assume if you're talking about a power loss, it's going to be, you know, more than 12 volts. I mean, it's going to be everything.
Okay, I thought this was your category. I thought we got this from you.
No,
How do you want me to
well,
rename?
no. So the idea is I, by my definition, I think I categorized, you know, there's essentially two kinds of fatal, right? There's fatal where you can't execute code. And I think that's your first one.
The fatal reset path? Yeah.
Yeah. And then there's fatal where you lose power. And the idea is that that can take many forms, right? And some of them are uh, with aux and some of them are without aux.
Right,
So
right. I think without aux we had, and we decided to delete it because there's nothing we can do about it. None of these work for that case, right? It was just we're
well,
helpful.
yeah, I would make no argument there. I think the point I would just make there is, you know, the only thing that's really required is some indication that there was an aux power loss. That's, right. When you lose power, and in this case, let's say all power, then there should be an indication that that's what happened. So when somebody comes, and looks to the logs, they can see that there was a loss of power and then a power restored. And those indications are important because you could see how long power was lost, that sort of thing. So
Or it may be the case that the power just went out abruptly and you couldn't get a message out, and the technician goes and looks at the rack and says, well, the LED's out. It's pretty obvious the machine doesn't have power.
yeah, I would, though, I guess my expectation would be that would all be managed, um, again, by the platform or the BMC in the event of the power loss. We typically do that in the platform. When we detect power loss, we try our best to manage the platform knowing that we're losing power.
You mean
And
like send a
obviously,
message out saying I'm going down because I lost power or something?
well, I think it's more, you know, trying to, you know, do housekeeping. Just
Okay.
and keep in mind that, right, we don't have a power supply that'll keep us up for a month, right? It's milliseconds. So we try to accomplish what we can in the limited time we have, but it's very limited, right?
Right.
So
Right. Right.
so the idea is what we would, I think what we should strive for is, you know, indicators that say, you know, we lost power and power was restored, and that's just for the case where we lose aux, you know, everything. Now,
Okay. So
for
let's
the
define this table as not that case. Let's just define this table as where we have aux, and then we'll have a to-do for uh, handling full power loss. But just so you
right,
know,
but you
we
should then describe the fatal power loss as, you know, so the idea is you need to describe what that event is,
well, I think we
because
did. What's not clear about this footnote?
what I don't see the footnote.
Oh, it's right here. It's because there's a page break here. Just put it in the middle of the table. That's all.
Yeah, so the idea is that you know, so all failures that still allow power to the BMC, I would sooner see the example, you know, an example of a power loss where that would happen. And as an example, a VRD. So I could lose a VRD, which would take away power from the platform, but not necessarily take away power from the BMC.
Right. That's squarely what under this category. Yes.
Right, but you're being vague by saying that, you know, housekeeping power is available to the BMC. I would rather just say fatal loss, fatal power loss events like VRD, and then, you know, right, for those type of failures, you know, there should be requirements in terms of, you know, how do you know it was a VRD failure when you get back to the platform? Who is responsible for that?
Okay. How about in this case, the CPU, the host CPUs are unable to run, but the BMC still has this. Okay,
Yeah,
and then what I'll
good.
do is I'll get rid of the footnote because that seems like it's not clear enough, and it was in a weird place anyway. Now, how's that?
I think that's better.
Okay, okay. So now back up to the comment. Okay, so let's see. Gosh, well, let's look at this one. So fatal reset. So I would argue that the infrastructure and application may work. Okay, so here's a question for you, Mark. I think that with this infrastructure case, um, I could see us writing the BERT. I don't know. Where does the, or is that really, that's really the OS case, right? For the OS first, does the BIOS read the warm reset and put it in the BERT for the OS to pick up on the next boot? And I think
Well,
it does. I think
well, it's certainly possible. I don't know that it's done that way, you know, all the time, but that is certainly possible.
so. Maybe I'll say may not be feasible here, and then I'll just say since this error is severe, code cannot. Uh, well, actually, I'm just going to delete this. So the put this at the end. Actually, I'll accept that. It'll just be faster. Okay, may not be feasible. So the OS crashed and was not able to log the error correctly, but some platforms might log the error BIOS and write it to the BERT. So what do you think of that?
That sounds excellent to me. I mean, right? There's a you want a description that is descriptive, and that one
Okay.
is. Yeah.
Okay. I'll accept that. Okay. Uh, let's see. And I was saying the BERT here, but with infrastructure, if you're in the infrastructure, you don't necessarily, that's not necessarily true. You may not be able to pick it up. So,
I assume that your firmware first feasible is just replicated in that column, right?
okay.
Because
I'll,
it's, ultimately, I think it applies everywhere in that column. The OS first, I think ultimately is in the same boat, right? Because it can't log.
I screwed
And
up. Hold on. Okay. I buy that. Well,
yeah,
the OS,
and the BMC is basically positioned to manage that event better than anybody.
yeah. Let's, okay. So, uh, okay. Are you happy with this?
Yeah, but I would replicate, your BMC to the 3 rows, and I would do the same with that first box in the OS first column because I think they're all the same.
Okay. Vilas may want to pull stuff out of the table, and if he wants to, he's not here, so he can just pull out.
We have carte blanche.
Yeah, that's the way I like it. Okay, let's just get it done. Okay, I'm aligned with you there. Oh, and let's see. Uh, oh, and this one, why didn't we say? Let's see. OS first. So it's
And
main.
well, so the idea is I think I would argue that one.
Okay.
Well, yeah, so this one is definitely gray area because it's non-recoverable. But if you use my definition of non-fatal that code can execute, then then that is not true. The idea is, the OS will have the ability to log the error, period. By
Well,
definition.
I guess what I was thinking is the OS may not have a way to put the error anywhere if IO's down. That was kind of the point. If
Then
IO causes a crash.
right, but then I would put it in a fatal category. I think my descriptions originally non-fatal by definition means that we can execute code, and therefore, by the mere fact that we can execute code, we'll have the ability to do everything we need to log. If there's something more then I would put it in a fatal category, and it says, ultimately, fatal means we may not be able to execute code, but it also indicates that the failure was severe enough that we will not be able to do normal housekeeping.
How about this?
Yeah. Okay. No. Good.
Okay, is that okay? I mean,
It's
I
okay
think
with
that's.
me.
I mean, so my point was, because I've seen this a bit where things weren't healthy enough, and I agree with you that if we call this situation the one where it is healthy enough, then we just say, okay, well, we assume that things are healthy enough to do it. So, and then I think we're good. Okay,
Yeah.
good. Um, and then I will say, I'll put the same assumption in the next one because his comment was, doesn't it mean it's not feasible? And I'll just say, we're assuming it's feasible if the OS and the IO are healthy enough.
Yeah. Okay.
Okay. So then this next one, okay, this said feasible, but I think it was just a bug. I mean, if firmware first isn't running if the CPU can't boot. Right, no power.
Right. But this is one I think goes into a different category because there's nothing that can be done to prevent the power loss. The question is, how do you log the power loss? And the idea is that I think in this case, OS first has no chance, but firmware first will, because the firmware will detect the event and log it post power loss. And BMC can, of course, log it as it happens, perhaps. But the idea is the platform will have the ability to detect the event and log it, but the logs will likely be post power loss.
How about maybe, so if you have the problem I see is that I've seen hard VR failures, and so the CPU just wasn't coming back. I mean, there
There
was
won't
no.
be there won't be a CPU coming back until the VRD is replaced.
Yeah, so that's the problem. So, like, if I'm managing my fleet, that's small consolation to me. What I need is to know that, hey, so this thing crashed. We can go send a technician out with, this VRD so that they can fix the machine.
Yeah, understood. And the idea is, that to me, I think there's two ways that can be done, right? It can be done via the BMC, obviously, and it can be done, in other ways in hardware, so that an LED is lit indicating the hardware failure. That's all done
Oh,
through the CP. That's all done through the CPLD.
right. Okay. I guess I don't really, that doesn't work for large scale things that well, because let's just say we ride bikes around our data centers and,
Yeah,
you know,
understood. I mean, again, this is obviously. I think I would agree that firmware first in that category is not feasible, right? And that you know, replacing the VRD, you could get but you still have to know to replace the VRD.
yeah, that's the problem.
And
Yeah, okay.
that can be managed in hardware, but that's not what we're talking about here, right? Certainly firmware would have to execute, and that's not possible with a failed VRD. So
Yeah.
BMC first is probably the only one there that I think would be feasible. But I would also put a note there that assumes that the hardware provides the capability for the BMC to detect the error. Right?
Okay. Assumes, how about assumes BMC can see the power failure or something,
Well, no,
or
No. So the hardware has to provide a way for the BMC to detect that there was a VRD failure, right? The idea is the platform will be powered off, so there will be very limited access. But the idea is I expect that the hardware will be configured in such a way that when a VRD fails, the BMC will have a way to query the CPLD to find the device that failed.
Okay. Okay, that makes sense. Can I call it, so since we don't always have VRDs, the D is down, and sometimes they're not down. Is it okay if we just put VR failure?
Yeah, that's fine.
The
And
same thing. But
yes, and that problem is getting worse, right? For DDR5, all the DIMMs will have their own VRs.
VRs, I know, tell me about it. Yeah, I know what you mean. Uh, okay, so I said assumes BMC can detect the VR failure. So does that satisfy your
Yeah.
concern?
Yep, absolutely.
Okay. So let's see. I think we've resolved that one. And I think we've talked about this table is, it is not aux power loss. We'll put that below.
Yeah.
And does fatal loss, okay, we said no, so we'll do that below again. And without power, BMC can't run the node, delete the period. Okay, so I think, so let's just talk about in the case of full power. We'll try to um, signal the problem as it goes down. It, or being to send a message before they go down. Otherwise, people servicing the machine have to go out and look at it. Okay, do you agree with that, Mark?
Yeah, I do.
Cool. We got through the section. All right. Hey, this is a great way to start the weekend.
Yeah, let's declare victory right there.
Yeah. Okay.
We're down to 5.
Yeah. So I mean, we can take a couple of easy ones. Okay. He says figure 4 needs caption. Let me see. Oh, okay. What do you all think of this caption? And this
I
is
don't
just
know what
showing.
you're I don't know what you're pointing at, Drew.
Oh, right here.
I still that the figure
Figure.
4 title.
Yeah, I just titled the figure, but I think it's pretty straightforward. This is just showing the BMC can log and we can send stuff to the host. And use redfish potentially. So any concern with the caption?
Uh, I'm just trying to understand the picture here. Why is EDPC part of this?
I think this is showing that the OS needs to see some things. So, like a synchronous exception, you've got to stop the OS before it uses something bad. With EDPC, if you support recovery, then the driver sees a -1 from config space, and from the particular place it read, it shouldn't have gotten the -1, so it infers that the driver's down and can bring the driver back up. But you have to expose that to the OS because the OS needs to see it to know that the IO device went down.
True, but that's a whole different kettle than BMC first error logging and OS visibility.
Well, it's just showing. I think it's just an example of the OS needs to see the error log. Like we can't hide everything. That's all it's saying.
Well, yeah, but you're not describing what error logs are going to be presented and why. I guess I'm just at a loss in that, I just don't see those comments essentially don't need to be there. This is BMC first error logging.
Well,
I guess I would say it this way. Let's call it BMC based corrected error logging, and then those exceptions and the DPC stuff go away, right? Because
no, we're covering every. We're saying that every. So okay, I'll give you an action item. I think it'd be good for you to read this section, but the point here is that just like the example we talked about. Let's say we have and we're about out of time, but let's say we have a poison consumption case. The OS has to see that. That has to be a synchronous interrupt. But the BMC wants to see it too, so that we know that a customer is having a bad experience. So the signal from the hardware has to go both places. Something.
Yeah. Well, I again, this is, when there is a poison consumption, the OS will see it because there's nothing the BMC can do to block that. And the question then is really, will the BMC see it? And in those tables, I think you said there will be a race-free method to guarantee the BMC will see it. It'll just be after the fact, which I think is acceptable.
Yeah, it could be.
But,
I mean,
but there's no HEST. There's no HEST for that, right? Because the OS sees the error directly.
No, that's for like a poison consumption. Let's imagine a corrected error where we end up cloaking because we don't want the OS overreacting to something like a single bit error in memory. What we would do then
then
is
HEST would be applicable, right? But then HEST would be applicable. I guess I would just say is, right, for me, the corrected errors, if this with title was for corrected errors and you were doing a HEST, that would make perfect sense. What doesn't make sense is EDPC and machine checks, right? Because both of those events, I think, would be directly visible to the OS.
Oh, that's what that arrow is. That's exactly what that's saying. See that arrow going from hardware to the OS? It's saying,
and that's clear. and because you've got the HEST picture in there, it looks to me like that's, that would be involved in all of these events.
No, the arrow doesn't point to the HEST. So
the HEST is still there, right? I mean, how does a user look at that picture and know there's no HEST involvement in a machine check and a DPC event?
So what we could do is make the HEST smaller and up against I mean, there are cases where we write the error from so where the OS doesn't need to see the error directly, like a corrected memory error, it goes up to the BMC, and we expose it, and that's all described in the text below, by the way. And so then we send the error to the HEST when we want the OS to do something, like map out a 4K page.
Right.
But then
When it's corrected errors, I think that's perfectly good. And when it's a machine check or poison consumption or EDPC, I
then the
think
OS has
that
to get it directly, and that's what we're saying. I'll
I
try. Let me take a pass at it, and I'll try to make it clear. But that's exactly what this is supposed to say.
yeah, I'm again, Drew, I'm just looking at it, I would have two drawings, one for correcteds that shows the HEST, and then another one for the machine check and DPCs that doesn't show a HEST because the OS is going to get it directly.
Um, Let me look and see if I think that fits. But I'll do something to make it clear. But I'm open to adding two drawings. Let me just fiddle with it and see.
Well, I'm open if you can convey it clearly. Because honestly, I'm looking at this and I won't say I've spent a whole lot of time consuming the whole document, but I will say that to me, when I look at this, it looks to me like the HEST is involved, all the time. It's not clear that that line, that arrow to the OS is, does not involve HEST.
And just incidentally, technically, when WIA was created, uh, they did ponder using the ability to use the HEST all the time, but I'm certainly not proposing that. But that's actually not a because you have to take an interrupt, right? And so
Yeah,
it's
I
like, well,
mean,
you use the HEST, what are you going to do?
that's right. In this case, I just think you need to, what's not clear is the BMC is going to be the second consumer, not the first. The
Well,
OS will be first for those events, right?
it's I mean, yeah, it could be parallel, it could be, but the OS is always going to be faster. I agree with you there. Um,
Yeah.
okay, let me try to take a stab at it. I'll see what I can do to make it clear.
Now we're down to 4. And we're out of
All right. Oh well. Well, hey, we're out of time, but this was good. We're getting there. I feel like we made some progress this week. So,
getting through the
well,
table was a big step. I think we should have celebrated that and declared victory.
well, I agree. I agree. In hindsight, what I learned, but it's good to know this isn't clear, and we can certainly make it clear. All right. Well, thanks. I think we're losing people. Happy
Yeah.
Friday. I will talk to you all next week.
Have a good weekend. Thanks. Bye.
Okay, you too. See ya.